Welcome back to the Foundation in C# course. We are currently in Module 8, and this lesson we're going to be covering LINQ and lambdas. Okay, these are tools that are really helpful, especially when we're talking about data access. Okay, so we're going to work with LINQ and lambda expressions. Now, lambdas can go well beyond what we're doing today, but this is basically in context of data access, and that will allow you to take it to other places as well. So let's start with Visual Studio. We're going to create a new project, and this is going to console app.NET Core. Now, we're not going to actually do any data access in this video. We're going to pretend we already have data existing. And the reason for that is because there's no need to scaffold all that out. We already understand how to access data. We've done it multiple times with SQL, SQLite, MySQL, MongoDB, Cosmos DB, text files, and APIs. So we're just going to worry about once we have the data in C#. Now there is a tool called LINQ to SQL that was folded into Entity Framework. We're going to cover Entity Framework in the next video. So this is not connecting to a database. This is just LINQ itself. So let's call this the add folder for models, and we'll create a model for, let's do contact. We won't do a full, contact model. I'm going to change it over here, and it's going to ask me, do you want to change the code element as well? Yes, I do. Public. There we go. Contact model. I'm going to have a few properties in here. ID, first name, last name, and we're going to have a list of type int, and it's going to be addresses. Okay? Now, that's just a list of integer, which means just the IDs of the addresses. Let's create another model. And this is going to be a class. We're going to call it address model. Don't forget the model this time. Make it public. And we're going to have prop, int ID, and then we're going to have string. Let's just do city, state, and just city and state. I'm not sure I want state. Let's just do city. We're going to keep it. Nope, state's fine. We'll keep it just those two. I don't want to go overboard in creating really complex models. I just want to have some sample data. Okay? So this, instead of void, is going to return back a list of contact model, which means let's get contact data. Control dot here to use our LINQ UI.models, and let's create an output. So output equals new list of contact model. Let's just create them all in line here. So new contact model. And inside here, we're going to have ID equals 1. Let's go back here and try and do it inline. First name equals Tim. Last name equals Corey. And then we can go here and say, actually, let's do addresses equals new list of int. And we'll have our values, let's say 1, 2, and 3, like so. Okay? And I think that should be it for that. It looks like it. We do need to then return output. Not outputter, output. We are missing something here because it looks like it's still yelling at me. Aha! I put a semicolon here. That does not go there. It goes down on the next line right there. That's why. And this would help if I put it on one line. So now I have a new list being created. I'm creating one record. Let's do a couple more. Let's do let's say 5. Like so. And not everybody's going to have multiple addresses. Let's just do a few, like so. And then let's not make every Corey's. That'd be boring. Smith, Jones, Storm, and I don't know. Let's go with Baggins. Okay, and we can change this to Mary, Jane, Sue, and Bilbo. Okay. Branton, and state equals PA. We put our semicolon at the correct location this time, and return output. And now we have this. We want to add a few more though. So let's do 3. Since that's the amount we asked for up above, 1, 2, and 3. So let's change our IDs first so we don't forget. There's 2. There's 3. Okay, so let's rename Scranton to be Virginia Beach. And this is in the state of Virginia. And this last one we'll keep in Pennsylvania. We'll make it Philadelphia. Okay, so there we have 3 addresses and 5 contact models. Now I can start working with them. We go back over to our program.cs and let's create a private static void. Let's go do lambda tests. Like so. The first thing we'll do is say var, this is going to be our data equals sample data dot get contact data. Okay, and that's going to list of all of our contacts. So let's talk about what a lambda is first. Okay, a lambda expression. what if we wanted to, let's say, filter this list to only people. Let's open back up so we can look at our contacts. Oops, not that. Sample data. There we go. Let's filter them to say, you know what? We only want people who have at least 2 addresses. Okay? Let's see if we can filter that. How we do that? We'd say data.where. We have to do control dot here to add using system.link. Now I've shown you this once, just briefly. I touched on it, but I didn't really go in depth into what's going on. I said we'd cover it later. Now is later. So we have where. And we start with, we say x arrow function x dot. I can do stuff. I'm going to write this out and then I'll explain it. X dot addresses dot count is greater than 1. Okay? And I'm going to put this into results. Now, what have I done? Well, probably if you are reading through it, it kind of makes sense, at least on the surface level, but you might not know why it's doing or how it's doing it. So give me the data where the addresses.count is greater than 1. Okay, that kind of makes sense. It's kind of like a SQL statement where you're doing a select from where and saying, okay, this is what I want. But how does it actually work? And what is this, what I called an arrow function that equals greater than? Well, this is a lambda expression. Now, it's part of the link namespace because this particular type of lambda is used in link. Okay? There's 2 ways of querying data, and that's what link does, L-I-N-Q. Link queries data, and you can do it via lambda expressions, or you can do it via a full link, kind of like a script or a statement. Okay? This is first the lambda expression side of things. So I'm going to say data.where. And what this does is it runs a method inside of this where I've got highlighted. Now, you don't see a method being called because lambda expressions are basically, they're one use only, they can be one use only methods, where you create a method and define it right in line. So instead of create a method down here, private, static, void, and create a method, and then saying somehow pass that in the parentheses here, instead, this is the method body, this is the method signature. And you may say, Tim, that doesn't look right. Sure, I get that, but that's all it really is. All right? So what's happening is they've kind of trimmed down a method. So let's look at what a method signature is. Private, static, void. Well, actually it's getting a bool in this case. But bool, and you know what? Yes, Boolean. I can, if I do a Control Shift space here, it goes off a screen, which really bothers me that it does that. But you can see kind of the edge of it over here. I wonder if I can fix that. I don't know if I can. I can try by doing this. Sorry, it's a kind of a limitation of my screen. Ah, no, it's still put in the same spot, which is just frustrating. If we try it again, now that I've moved it over a little more. No. Come on. All right, there we go. Now let's actually freeze this and capture it. Okay, so the where statement, okay, that's this where right here. It's taking in a type of contact.model that's being inferred based upon this type right here. So it says this is a list of contact model. So this where clause is going to operate on every one of those items individually. So it's taking in a contact.model. And it's going to call, we're going to pass in a func. Okay? F-U-N-C. Func. And what that is it's a special method that you create that what it's going to do is it's going to run on every single item in that list. Now, we're going to pass in a contact model, and we're going to pass out a Boolean. Now, how do I know in and out? Well, all the last value in a func is the output type. All the rest of the values are input types. Okay? So that's the method we're going to create. An input that takes type contact model and output of type Boolean. That's the method we need to create and put in this spot right here. All right? Now we did that with this line right here. But how does that actually work? What does it mean? Well, let's zoom out and figure that out. So let's define this method right here by writing it out. Public static bool run me. Okay? It doesn't really matter. It takes in a contact model, which control dot to add our using statement and call this, let's call it contact. And then, actually, let's not call it contact, let's call it X. And then in here, it's going making things a little better. How can Microsoft make things a little easier? We're going to want to do it in line. And so Microsoft said, you know what? There's an awful lot of things we can assume. Okay? And we can make an assumption on based upon how you're using this. So for example, private doesn't really matter because you're saying, I want to be able to call this inside this where. So we don't need to have an access modifier. Get rid of that. Static, don't need that either. We can infer that based upon where it's at. Return type, I'm going to need that, but at the same time, when you defined this where clause, you said it's a func that takes in a contact model, returns a Boolean. Therefore, you don't need to tell me what you're returning, return type, because I already know what that return type is. Therefore, get rid of that. Now, do we need to name a function? Nah, don't need a name for it because we're just going to call it. So get rid of the name. Now, I already know what the input type is. I know it's contact model. Therefore, I don't need that either. Now, I don't need those curly braces. That's kind of silly. So let's get rid of those. And the only problem is now I've got to separate my signature line from my code line. Let's do that with an arrow function. Okay? So we're going to say this is the signature, this is the code. Ignore the red squigglies. Now, we don't necessarily need the parens if we have just one item. Okay? So let's get rid of those unless we have 2 or more, in which case we'll just comma separate them and put them in parens. We don't need a return statement because we already know that there's only one line in here and that's going to return, therefore get rid of the return statement. And we don't need a semicolon because it's just one line. Therefore, get rid of that as well. And look what we have left. X arrow function x.addresses.count is greater than 1. X arrow function x.addresses.count is greater than 1. So this right here is a method that's just been stripped of all the things that Microsoft can assume. When they created this where clause and they said it's a func, which is a special type of delegate, it's a func that takes in a contact model and returns a Boolean, then it says, okay, I know these values, therefore I can assume what the output type is going to be, I can assume what the input type is going to be. We're all good, just include the bare minimum. And that's what we do with Lambda expressions. We do just the bare minimum that is unique to the method. We don't have to create all the extra stuff around it. Okay? So, I give it a variable name. Now again, that variable name, just like when you put it in a method, you can, parameter name. That parameter name can be anything you want. We typically use one letter because it's short and it allows for this whole statement to be a little shorter. So I just said X. I could say, you know what, this is contact information, so I'll call it C. It makes a little more sense, okay? That's fine too. This only lives for the life of this method. Now, there's still some, I don't want to call it magic, but some really cool stuff going on here. The where clause is going to operate on every single entry in the data collection. So it's going to say for every single entry, pass it in and figure out if it should be included in the output. That Boolean, true or false, is going to tell you yes, it should be included in the output, or no, it shouldn't. So when it captures all those values in the for each, then it will create a new output, which is going to send into our results. And that results list will be just the values where the addresses.count is greater than 1. Which means we can do a for each item in results, and then do a console write line with a string interpolation, and say item dot first name space item dot last name. I think that's all we need. We don't need to have all the rest of the information. We should just get back Tim Corey and Bilbo Baggins. All right, let's run this and find out. Well, we're not going to get anything back because I never called Lambda tests. Let's try it again. Tim Corey and Bilbo Baggins. So that's our where Lambda expression. So that's our first Lambda expression, but let's go a little deeper and try some others. So var results, I'm using var intentionally because we're going to start modifying these, equals data dot select x arrow function, x dot, let's just say, first name. Okay, and now our results is an enumerable of type string. Isn't that interesting? We're taking in a list of contact model and we are outputting it to type list of string, which means I can't do this first name and last name and all the rest. So let's do this. Let's cut this line out real quick. I'm going to comment this out as well. That way we can keep these kind of together. Okay, I want you to have these to play with. So now let's paste this in, and we're going to do a for each item in results and we're going to do a console write line results, just the string results. And let's see how this looks. And it goes, yeah, you can't do that. Okay, because each item is, I printed out results, not item. Let's try it again. And now it says Tim, Mary, Jane, Sue, and Bilbo. So it's grabbed just the first name, but it created a whole new structure for me. I said, just give me the first name, don't give me the last name, don't give me addresses. So I have trimmed down my object, create a brand new object, okay, which is a list of string. All right, let's keep going. So we're going to comment this out, and we'll say again, var results. I'm naming it results each time, so make sure you only uncomment one section at a time. Equals data dot take. Okay? And with take, what we can do is we can say, how many do I want? Just 2. Okay? Now let's grab this for each. And I will paste it down below and I'll uncomment it. So that's again, first name and last name. This is still an IEnumerable of contact model. And I can say run this and I get Tim, Corey, Mary, Smith. That's it. Because I said just give me 2. We could also go a little further and say, you know what, I'm going to copy this and then I'm going to comment it. I'm going to paste another section here, but this time instead of just take, I'm going to say dot skip, and let's skip the first 2 and then take the next 2. And if we run this again, we get Jane Jones and Sue Storm because we skipped myself and I believe Mary. Okay, myself and Mary. Yep, we got Jane and Sue after that. So we skipped the first 2, then we took the next 2. Okay, but notice how I can also chain these together. Now let's comment this section out. I'm going to copy just this though first. And I comment this out. And I'm going to say right down here, var results equals data dot, and let's this time do an order by. We're going to say lambda expression x dot, let's order by last name. Okay, and then we'll loop through all of these. And there we go. Baggins, Corey, Jones, Smith, and Storm. Now it's been sorted or ordered by the last name. Now, what if you wanted to order by descending? Well, you'd actually just do order by descending instead. Now, if we run this, it'll be in opposite order. It'll be Storm, Smith, Jones, Corey, and Baggins. Okay? And again, you can chain these together. So we could do a where, we could do a select, and a take, and a skip, and an order by all together. Now, there are more lambda expressions, but I think that gives you a good set to play with, the most common ones. Okay? So those are lambda expressions, and they're pretty powerful on their own. They're basically shortcuts to allow us to very, very quickly do some type of SQL-style operation on our set. Now let's look at some more precise, I guess you could say, or more specific ways of doing link. It's a lot more SQL-like than even lambda expressions. So private, static, void, link tests. And the first thing we'll do here is say var, we're going to say var contacts equals sample data dot get contact data, not get address data, get contact data. and then var addresses equals sample data dot get address data. Okay, so now we have both lists. Let's look at a link query. So var results equals parentheses from C in contacts. Now, what am I doing here? This is a link statement. It looks a lot like a SQL statement. One of the things I love about it, though, is that it gets the order right. So in SQL Server, you say select, and I typically do select star from and the table name. And then I go back and change the star to the values I want, because then IntelliSense works because it knows what table I'm talking about. With this link statement, it gets the order right. You start with from. Where are you pulling the data from? And then after that, you do things like where. And then after that, after all that, then you do your select. Okay, so let's say from C in context. C is an alias, whatever you want to call it, but you have to have it be an alias. All right, so from C in contacts, and then we're going to say, let's do a little bit of a delimiter here, because I think you can understand more than one statement here. So where C dot, check this out, addresses dot count is greater than 1. Select C. Okay? So what's this doing? It's looking at the contacts and saying, name each one, or the table C. And you're going to say C, which kind of represents one row, just like it does in SQL. C.addresses.count is greater than 1. So filter this contacts list to only people who have address counts greater than 1. And then select C. Remember, C is a contact object. So we'll have a list of contact objects. We mouse over results. It's going to say that it's an IEnumerable of type contact model. Okay? But we can go even further than this. What if we wanted to, instead of doing this where clause here, and I'm going to copy this and comment it out for you. I didn't actually show you it worked, but it does work. Okay? But instead of doing this where clause here, before we do that, let's bring in our addresses. Because right now in contacts, we have just the ID of which address we have linked. Okay, so we have 1, 2, and 3, 1, 2, 3, and 2 and 3 in the addresses list, which is a list of int. Instead of having this list of int, I want a list of addresses and bring these addresses in here instead. Well, just like in SQL, we can do a join. Okay, so we're going to join, and we'll call it A in addresses. My other list. And we have to say on C dot addresses dot. Actually, as I'm looking at this, I think that this is going to be too complex an example. I'm going to rework it slightly. And the reason why is not to try and cop out of showing you a more complex example, but it's more I don't want to overly confuse you. I want to show you the more traditional way of doing things. So what I'm going to do is I'm actually going to rework the contact and address. Actually, just addresses. So we have addresses. We have its ID. I'm going to add one more property here. So I'm going to go over to my Solution Explorer. I'm going to pin this and go to Address Model. I'm going to add a prop for the contact ID. Because right now what we have is a many-to-many relationship, and that's not ideal for this because it's going to bring in more models in order to link this all up. It's going to be a little confusing. So I'm going to do a one-to-many relationship. So we're not going to have an address duplicated for a person, okay? So let me go back over my sample data, and we're going to add in that contact ID equals 1, like so. And we'll do that for these, and we'll change this one to be 2, and then let's do some copies here, like so. And we'll make this 3 and 4, and we'll do it again and make this 5. And this last one we'll do, we have 1, 2, 3 threes. So this last one we'll make a 1. Okay, so number 1 has, oops, wow, make this, I see what I did. 1, 2, 3, 4, 5, 6, 7. Wrong ID. So 1, 1, 2. This one is a 3, a 4, a 5, and a 2. So nope, not a 2, a 3, because 2 already has Philadelphia. So now we have an entry for, wow, I missed 5. There we go. So now we have 2 entries for contact ID number 1, 1 entry for number 2, 1 entry for 5, 2 entries for 3, and boy, let's do this. 2 for 5, 1 for 4, and 1 for 3. That way 5 has Virginia and Philadelphia, 4 has Virginia, 3 has Philadelphia, 2 has Philadelphia and Virginia, and I have Scranton. Woohoo, go Scranton. So, or I have Scranton, Virginia, sorry. And that's a good combination for me. I like that. Anyways, and I'm going to ignore this addresses list here, okay? So the way we're going to link this is a one-to-many relationship where you have one record that can have many entries in the address list, okay? But notice we have duplicate addresses here because different people, so 5, 1, and 4 all have Virginia Beach addresses. But we've duplicated them because we can't have 2 contact IDs in this address, okay? This is just going to make it a little easier for working with our link. Actually, it's going to make it a lot easier. And this is more what you'll see normally. You can extrapolate a little bit to figure out, remember we did the design in SQL where we had that middle table between the two, where we had a contact and an email address, and in between we had contact email and that list. That's kind of what we'd have to recreate in this code. I don't want to go that far. So back over in program, let's now do our link, okay? So we have from contacts, join addresses on c.id equals a dot, eq equals a dot, and this is the contact ID. And what this does is it links in the address record based upon the contact ID matching the address's contact ID. Okay? Which means now we have the ability to look through these. Now let's grab the for each statement here. I'm going to copy this, and we're just going to look at what the results of this are. All right, so let's uncomment this, and we're going to run, I didn't actually call this. Link test. Now I can run this. It happens almost every time. So we see Tim Corey twice, Mary Smith, Jane Jones, Sue Storm, and then Bilbo Baggins twice. Well, why do we have 2 people that are repeated twice? Well, if we were to expand this and say first name, last name, we could look and see that they actually each have 2 addresses. But we never captured that. We just captured the contact record. So let's modify this a little bit by saying, well, what if we did c.firstname comma, C dot, I have to put this in parens here. So to say select new and curly braces here, and then close my curly braces. And it's going to create a new object, brand new object, a different type. C dot last name. Check this out. A dot city. A dot state. Now, what is this type that I just created? Well, it's a new anonymous object, which means result is now a collection of anonymous. Okay, A is essentially anonymous. I can still do my for each. It will still work because even though it's anonymous, it has a first name property and a last name property. But now I could also say from item dot city, comma, item dot state, like so. And now if I run this again, Tim Corey from Scranton, PA, Tim Corey from Virginia Beach, Virginia. All the way down the list, Bilbo from Virginia and Philadelphia. Okay, so now we've created a brand new type. And that's one of the reasons why var was created. It's not just a shortcut, although that is a helpful situation where you don't have to say list of type contact model. We can just say var. And that knows, based upon what you put into it, what the value is. But with this, we don't even have a type. We don't have a name to give it. It's anonymous. And so we use var because that way it can say, yeah, the type doesn't have a name, but we know what's in it. And so that's all we have to worry about is what's in it. And so therefore we can loop over it, or for each, and we can use each item with strongly typed properties, even though there's not a class called, well, I guess we call it A, whatever it is, that results. It's calling it A, actually tick A, because it's a new anonymous object. But here's the definition. Okay, so we want the list of all the addresses. Well, we could say addresses, which where's addresses come from? Well, that's up here, this list. Dot where lambda expression, so x lambda expression. So x is now each item, each address, where we could say x dot contact ID equals c, double equals c dot ID. Well, how does that work? Well, we're saying give me the ID from C, which is from contacts, and match it up to x dot contact ID. But it's saying, hey, you don't have a name for this. How about addresses equals? Okay, so I just give it a name and said equals, and then here is the expression to put in. Now, what's my result type? Well, it's another one of those anonymous types. However, I can do my for each, and let's copy this for each, and we'll paste it in. Only this one, we gotta, first of all, uncomment, and we can't do from city state because that doesn't work. we don't have city and state. We just have first name, last name, and addresses. So how about addresses, item dot addresses dot count. Okay, and this will be the count of the number of addresses. The count of the number of addresses in this person's object. Let's run this. And it does not repeat Tim Corey. He's only there once, but it says, hey, he's got 2 addresses in there. So does Bilbo. So now there is an IEnumerable of type address model inside of the Tim Corey object that's each of those addresses. Let's just put our breakpoint here so you can see one of these objects to see that in fact there is addresses in here. Let's run this, and now let's look at item.addresses. So in the local item.addresses, and we'll look at the results view because this is an anonymous object. There's 2 of them, and one is for Scranton, PA, and the other is for Virginia Beach, Virginia. So it has 2 objects in there, and they are the full object. Okay? Now you know how to do this. Let's take it one step further. I'm going to copy this and comment this line of code out. And then I'm going to paste it back in. But we're going to make some modifications. Because this right here, that's cool, except for the fact that right now I'm saying this is a one-to-many relationship. But now you've seen how to do that, maybe we could come back to this issue right here where we have this list it's a many-to-many relationship. Could we maybe bring these in somehow? Well, let's come back here and look. We're bringing in the addresses list, cool, where, and we're saying we're linking the contact ID to the ID of the contact. So in the address list, this is let's call this A instead of X now. Makes it a whole lot clearer. So in the address, the contact ID is going to match the ID of the contact. Okay, but what if we flip this on its head? Okay, so let's back this out and let's unpin this as well so we have a little more space. And we say where C, which is our contact, dot addresses. That's that list of int. Dot contains, and it's looking for an int. Well, what int do we have? A.id, the ID of the address. All right, now let's do the same thing. We're going to get the counts. But remember that over here we have 3 and then a whole bunch of 1s and then 2. Let's see if we get the count 3, 1, 1, 1, 2. And we do. We've now done a many-to-many relationship. So we can get there. It's just that it takes a little bit of kind of twisting your brain a little bit to see how this would line up. Okay, so we said find all the addresses where the address ID is in the contact's addresses ID list. And that creates a new object, first name, last name, and addresses. So now instead of a first name, a last name, and a list of int, we have a first name, a last name, and a list of address model. Okay? See how LINQ can kind of merge these things together and do some really cool query-like syntax. Now, this does take some getting used to. These kind of LINQ statements right here, they're a lot more SQL-like. So if you're familiar with SQL, these will come a little more naturally. The big things to note are things like equals in your join is equals, not an equal sign, and that it goes from down to select, not select and then from. But if you're not familiar with SQL, then this might not be quite as intuitive. But that's why we have the lambda expressions. If you just need to do a quick where clause or a select or a take or a skip, you can even do group bys and order bys, all those kind of things with lambda expressions, then you don't have to write the full statement like this and maybe get a little confused. That's kind of the benefit of link and lambda. They go hand in hand, but it's really quick to do lambda expressions for quick little things. But when you need the power of doing something a little more complex like this, then you can do a full link query, okay? And you can even create new objects and new structures. The really neat thing is you can even map to existing models. So instead of saying new and then blank, you can say new person model and then fill in the values based upon your query of a different type of model. So you basically transfer from one model type to the other. There's a lot of things you can do in link. Okay, so when you need that extra power or you need to transform an object, probably the way to go is a link query. But if you just want something quick, which we've done before in previous lessons, where I'm like, okay, I'm going to talk to you about it in just a minute or in a couple lessons, but we're just going to use a where. Okay, you know, we did in a couple lessons ago, we did a where clause, and I said, okay, we're going to talk about that. But that's all there was to it, is just that right there. And yes, it does have that lambda syntax, which gets a little bit, takes a little bit of getting used to, but it's more a matter of just using it rather than it being super complicated. It's actually removing a lot of the complication. Okay, so you have your options here of how to play with your data. But I do want to point out that both link and lambda are working on data that's already in C#. Now, there was a tool that was folded into Entity Framework. It still kind of exists, but it's in Entity Framework, that was called Link to SQL. And the idea was that it was actually data access and querying. So you'd query using link, and you would do so right against SQL. And now you do that inside of Entity Framework. Now, the benefit, and we'll see this in the next lesson, but the benefit of using link and knowing it for Entity Framework is the fact that these queries can actually be run on the server before we pull down data. But normally, when you're working with data and you're using link, it's already in C#. And so I want to show you, working with data in C# already, how to do link and lambda, so you can separate that out from just Entity Framework. Entity Framework will take advantage of these things and in some ways make them better, but I did want to show you that this is just on its own standalone, that whenever you have data, you can work with it using link and lambda expressions. All right, let's look at today's tip, and that is use link statements to make your code more readable and simpler. Now, link statements would be those actual lambda expressions. Okay, there's link queries and link statements. Now, a link statement is that, let's actually go back to the code here and look, this right here. That's a link statement. Okay, so data.where address count is greater than 1. That makes it pretty understandable what's happening here. It's very readable. Okay, so you can use those link statements to make your code more readable and simpler versus creating a for each loop and pulling out only some of them and creating a new variable or new object and then return that object. Basically do it on your own. Okay, so use link statements to make your code more readable. All right, so your homework is to create a list of person model and filter the list twice. Once using the query syntax and once using the method syntax of those lambda expressions. Perform at least a filter and a sort each time. Okay, so at least pull some objects out and at least order them each way. Okay, so give that a shot. Once you are done the homework, then move on to the next lesson where we'll cover Entity Framework.